Hey, this is Mr. James. In this video, we'll show you how to do some algebra problems and some harder problems with parallelograms and parallelogram properties. Now, we're going to be working on a stations activity with parallelograms. Okay, and so let's take a look at the stations activity right now. Okay, it should look like this, right? You'll see this. The first two questions right here are kind of basic questions for every page. There are 4 pages, right? 1, 2, 3, and 4 is on the back, so there are 4 pages. The first 2 questions on each page are basic questions that just deal with numbers. The next 2, 3, and 4 on each page are questions with algebra, and question 5 and sometimes 6 are challenge questions. So what do I actually want you to do today? Well, I want you to know that I want everyone to finish the basic problems on every page, the first 2, and the algebra problems on every page, 3 and 4, and at least 2 of those difficult problems, 5 and 6 at the end. If you happen to finish more than 2 of the difficult problems, you can turn in your paper and get some extra credit. So the more, for every difficult problem you do after the first 2, I'll give you 10 more percent. So if you do 1 extra, you'll have 110%. If you do 2 extra, you'll have 120%, and so on. So what I'm going to do is for each page, I'm going to demonstrate how to do some problems, not from the page, but some general problems like the ones on the page. And then you can pause the video then and go ahead and try those problems. So let's get started. Remember, you can pause the video here if you want to read these instructions again. Alright, go ahead and turn to the first page, but don't start just yet. I'm going to talk about some of the problems on page 1 with basic angles and parallelograms. What do we know about the angles and parallelograms? Well, we know that 2 angles, such as E and G, that are across from each other, that are opposite each other, are congruent. So angle E in this picture would be 138 degrees as well. We also know that angles that are next to each other, okay, that are consecutive, one after the other, they add up to 180. They're supplementary. So I would do 180 minus 138 and get, let's see, 42. So F would be 42 degrees. And we could even fill in D with 42 degrees as well. Okay, again, angles that are across from each other, like S and Q in this picture, are congruent, whereas angles that are next to each other, that are consecutive, are supplementary, which will make this, let's see, 82. Okay, add it to 180. Let's add some algebra in. Let's look at this problem. Number 5, find the measure of angle K. Well, before we can do any of that, we need to set up an equation to solve for x. That's the first part of any of these problems, solve for x. Let's look at these 2 angles they give us, this one and this one. What do we know about those 2 angles? Well, we know that they add up to 180. Whatever those 2 angles are, they're going to be supplementary or add up to 180. So I can write an equation where those 2 angles add up to 180. So we'll start with 120 x plus the other angle, 61 minus 1, equals 180 degrees. Okay? And then I can go ahead and solve that. So let's see, combine like terms. I'm sorry, this was 61x. Combine like terms and I get 181x minus 1 equals 180. Then, okay, I can add 1 to both sides. Okay, and then I get 181x equals 180. And then I can divide, 181. I can divide both sides by 181. 181 divided by 181. I get x equals 1. So x equals 1 here. Am I done? Well, not quite, because the problem wanted me to find the measure of angle K. So here's angle K, 61x minus 1. So I'll take my x equals 1 and plug it in. 61 times 1 minus 1. Let's see, 61 times 1 is 1, minus 1 is 60. So angle K is actually 60 degrees. Now, what if we didn't have this angle here, this angle here? What if we had 2 different angles? Well, let's see what that would look like. So what if I cross out the 120 and instead I've got this angle K and this angle M? Well, remember, those 2 angles, they're no longer supplementary. They don't add up to 180, but they are exactly the same. They're congruent, right, from some of the problems we did before. So instead of having them add up and equal 180, they'll equal each other. So 61x minus 1 equals 3x, okay? And then I'd solve just like before, figure out what x equals, okay? And then plug that big in to figure out what k is. But I'm going to stop here for now. This is the end of number 1. If you'd like to, go back and replay anything I talked about with page number 1. Otherwise, pause the video here and try out page 1 on the parallelogram stations, basic angles. Okay, now we're going to talk about page 2, which has to do with the sides of parallelograms. And this is probably the easiest page that there is. What do we know about the sides of parallelograms? Well, we know that the opposite sides are congruent. So if one side is 18, then the opposite side is also going to be 18. Okay? Let's say the side was 5. This opposite side will also be 5. So let's apply some algebra to that. If we've got these two sides, DC and BE, DC is x plus 22, BE is 2x plus 22. How can we write an equation to solve for x? Well, let's see. We know that those two sides are going to be equal, or congruent. So when we write our equation, we can set the two sides equal to each other. So we have x plus 22 equals 2x plus 22. Because remember, these opposite sides are equal to each other. Okay? And we could do a solve. Let's see. Let's subtract 22 from both sides. Okay, subtract 22 from both sides. That cancels out. That cancels out. We get x equals 2x. Okay? We can go ahead and subtract x from both sides. 1x. We get 0 equals x. Okay, so that's it. 0 equals x. Then we can take that answer and plug it back in to find what DC is. Here's DC. 0 plus 22, which is just 22. So DC is 22. There it is. And that's how you do algebra problems with the sides of parallelograms, right? Just remember that the opposite sides are always congruent. One last bit of information before we leave. Let's say I give you a problem that looks like this. Here's your parallelogram. Here's 3x. Here's 5x plus 1. Here is 2x minus 3. Okay? We know that these two sides will be congruent. So we could write an equation that was 2x minus 3 equals 5x plus 1. We could do that. But we don't know anything about this side, right? Because there's nothing across from it. So actually, we won't even use that side in our equation. We'll just use the two sides that are opposite each other. Okay? You'll see a problem like this in question 5 on page 2. Pause it here and try out page 2 before going on. Alright, so once you're done with page 2, we're on to page 3, advanced angle problems. So these are angle problems that start to have some diagonals. Remember, diagonals are any of these segments, like this green one here, or here, or here, those are all diagonals, that are segments that connect two of the vertices of a quadrilateral or any polygon that kind of go through the middle of the shape. So those are all diagonals. Okay, so let's talk about how to use those diagonals. Well, in this problem, this is angles 46. We need to know what this angle is. How can we do that? Well, let's remember what a parallelogram is. A parallelogram is a quadrilateral with two pairs of parallel sides. So these two sides in red are parallel. The diagonal, right here, kind of acts as a transversal. And if you remember back to the beginning of the year, now these two angles here, 46 and the question mark, look like alternate interior angles. And what do we know about alternate interior angles? Well, they're congruent. So if this one's 46, this is also 46 degrees. The question mark is 46 degrees. Question 10 is a little bit harder, right? We've got these angles of 31, 115, and the question mark we're trying to figure out. Now there's more than one way to do this problem. I'll show you a couple ways. You can choose whichever one you prefer, and there's even more than what I'm going to show you. What you could do is say, okay, this is 115. So this whole angle right here, okay, is going to be 115 minus 180. And that's because, remember earlier in this video, we said that any two consecutive angles that were next to each other in a parallelogram add up to 180, and this is no different. Okay, so 115 or 180 minus 115 is 65. So this whole blue angle right here is 65. And since this right here is 31 degrees, what will this be? Well, 65 minus 31 is 34. So that angle right there is 34 degrees. Okay, there's actually another way we can do it as well. instead of doing that, we could say, okay, this question mark angle is actually the same as this angle over here. Put a question mark there. And if we look, now we've got a triangle. We've got a triangle right here. And we know what two of the angles are, and we need to find the third. So we could say we have 180, because that's what all the angles of a triangle add up to. 180 minus 31 minus 115, let's see, equals, throw it in the calculator, 34. So this angle right here is 34. And so this question mark angle is also 34. Remember, those are alternate interior angles that we learned from the previous problem. Let's add some algebra to this, right? Let's add some variables. Okay, problem 11. Find the measure of angle DFG. Okay, well, we'll do that in a second, but first we've got to somehow write an equation to solve for x. Now this is a harder problem. So what I recommend doing whenever you see a harder problem like this is just writing down everything you know. What do we know? Well, we know that this 10x minus 5 will be the same as this angle over here, right? Because they're across from each other, they're on opposite sides of the parallelogram. So 10x minus 5 will go there. Okay, what else do we know? Well, we know that this 37 will be the same over here, because those are alternate interior angles. Okay, and we know that this angle here, 4x minus 6, will be the same as this angle here, 4x minus 6. And then we stop and we look at it. We think, oh, hey, this is a triangle. Right here, there's a triangle. And so we could say that all of the angles of that triangle will add up to 180 degrees. So we could write an equation like this. 4x minus 6 plus 37 plus 10x minus 5 all add up to 180 degrees. Okay? And then you could combine like terms, you would solve this, and in the end you would figure out what x equals, right? And plug it back into DFG to figure out what DFG is. So we plug it back into DFG right here, this 4x plus 6. Right? We're going to stop here, try out page 3, pause the video, and when you're done, come back to see how we can do some problems on page 4. All right, this is page 4, all about the diagonals of a parallelogram. Now diagonals, got something interesting about diagonals that we need to know. Okay, we have a parallelogram, and those are the diagonals. The diagonals actually bisect each other. That means that they cut each other in half. So these segments are congruent, and these segments are also congruent, right? So this point in the middle is kind of like a midpoint. How does that work with problems? Well, let's start with this one. We'll start by labeling our diagram. So EB is 10.2, and EG, E to G, well, we need to find that. Okay, well, if this half is 10.2, since this diagonal right here, okay, is cut in half, that means that these two halves are congruent. So this other half is also 10.2, and so the whole thing is 20.4, so EG is 20.4. Okay? In this next problem, let's see, XC is 21.4. XC is 21.4, and they want to know what CZ is. What CZ is? Well, this one's even easier, because we know the diagonals, they're cut in half, so those two halves are congruent. So this other part, CZ, is 21.4. It's 21.4. Let's do one problem. Let's use some algebra for this one. Okay, let's look at number 8 here. 8 says FC is x plus 13. So F to C is x plus 13. And FH, F to H, is 3x plus 17. Well, what do you know about those? Well, they're not equal to each other because 3x plus 17 is much bigger than x plus 13. But we do know if this is x plus 13, this right here is also x plus 13. And now we can write an equation where this side, okay, is congruent to these other two sides put together. So we could write that 3x plus 17 equals x plus 13 plus x plus 13. Okay? And then you can combine like terms, solve, and don't remember at the end to plug back in to find what FH equals. You might also come across other problems like this one right here, where you've got a measure for both halves of the diagonal. In that case, remember, those two halves are just going to be equal to each other. Okay? Now that I've shown you how to do some problems on like page 4, go ahead, pause this here, try out page 4, See what you can do. Good luck.